Now we're gonna do the collision separation algorithm of circles. So this is my constructed separation algorithm. Let's try this. Let's run this program. And yep. So if I click this button, if there's no collision, it is reported here. If there's a collision, yep, we can see the before, the position of these two circles before they got separated, and this is their position now after the separation. As you can see, both of their positions have changed, and we're going to reconstruct this. So get this file, drag it here, and let's start modifying this. These are the variables that we need. These variables are related to the dragging mechanism of this program, so we don't need to worry about this. Just this, we need this to accomplish the collision separation algorithm. Yeah, circle object. I already introduced this circle object, and yep, update the centers, and yeah, check collision. First we need to check for collision before we separate both circles. This is a circle to circle collision. I already discussed this, no need to discuss it here. And button action, if there's a collision, then we're gonna execute or invoke this method, the separation algorithm. Yeah, in this method, if there's no collision, then yeah, no collision. And that's all. Now go here to the separate circs method. We're gonna reconstruct the algorithm that I implemented here. We're gonna reconstruct here. Let me explain the algorithm that we're going to use before returning to coding. Suppose two circles collide and we verified they collided. Now we want to separate them. To separate circles, we need to get the right triangle in between centers and find its x and y components. Then use arctangent to get the angle. Then use cos and sine function to get the x and y components that we need in order to distribute the overlap vector without changing its angle. Then find the overlap vector. Use the product of cos and sine that we used earlier to break down the overlap vector into x and y component. After that, distribute the overlaps x and y components to both circles or a circle of your choosing. And this algorithm is slow because this algorithm relies too much on slow built-in methods like cos sine methods. So it's not recommended to be used in practice. I only show this solution for the sake of increasing our knowledge about circles. I'll show the other simpler and fast methods later. So first, pause the video and copy. Write this. After that, this is a I would like to call it a debugger, so we can see the changes before and after the separation. When the separation happens, we need to know the before and after position of both circles, and put this, write this in your code, and now we have before and after information that we need. Now let's write the algorithm. So first, create a float and name it adjacent equals to use math.absolute and compute the x length of both centers. Good. Next is the opposite and compute the y length of both centers. Center y, and done. I wanna mention, just wanna say that this the algorithm that we're gonna do here is slow and not recommended to be used in practice. I just wanted to show this to improve our understanding in understanding about the circle separation algorithm. I'm going to show 3 ways of separating two circles that collided. So I'm gonna show the first one, the slow algorithm for separating two circles. We're gonna do the na wait. We're gonna do the simpler algorithms later, and those algorithms are much faster. Uh, Create another float and name this angle. This will hold the angle that we're going to use later. Now we have the opposite, adjacent, and angle variables. Now we'll create an if statement and check if adjacent is 0. If it's 0, then set the angle to 90 degrees or 1.5708 radians. We need radians here, so convert degrees to radians. If the adjacent is 0, then angle equals to, put this to, we're going to cast the result of this arc tangent. So math dot arc tangent or atan, and put the opposite over adjacent, and done. We need this condition because if by any chance this adjacent got 0 result, or 0 value, then this equation is going to be undefined because it cannot divide by 0. So if that happens, then we don't need this. Instead, set the angle to 90 degrees or 1.5708. I set this to 90 degrees because we're gonna use the cosine and sine function, and I'm gonna open the calculator. When we use cosine 90 degrees, the result is 0, and when we compute the sine of 90 degrees, the result is 1, which is the exact value that we need when the right triangle in between centers is perfectly aligned in the y-axis. Because if the adjacent is 0 and the opposite has value, then it means that the right triangle is perfectly aligned in the y-axis. If opposite is 0 and adjacent has value, then the right triangle is perfectly aligned in the x-axis. And that's all for this. Let's move on and create variables again, cos x, and use math.cosine and angle. Put the angle here, must be in radians, not degrees, and sine y. Use the sine and the angle, and done. Next is create another float, call this center radius, or the hypotenuse in between centers. Let's call the center radius, and yeah, find the square root and put the radius here. This radius. So this radius is the hypotenuse of the right triangle in between centers. Yep, if we can get that in the when two circles collide, yep, we can get the center radius or the center hypotenuse, if you will. So if there's a collision, get that. That's why by using this method, the check collision, where is it? Yeah, this circle to circle collision, and this method will return the center square. Yep, it's a center square, and we need to get the length, not the squared form, so I used the square root. If you insist to use the squared form, you will have a inaccurate result here. Better use the square root. So if there's a collision, this method will return the total center square and set the value of is colliding to true. Otherwise, it won't return anything or any values and set the is colliding to false. Alright? So put the radius here, and as you can see, I'm using lots of slow methods like the arctangent, the cosine, and the sine and square root. That's why this algorithm is not recommended to be used in practice, because this algorithm is very slow. Once I'm done showing this algorithm, the two remaining methods are good and fast, and it's better to be used in practice. So center radius, create another float, call this total radius, and yeah, c1 dot get radx, get the total radius of both circles. Get rad x. I'm going to use the radii of these two circles that are aligned in the x-axis. call this overlap, and this is the overlap between circles. To get this, just find the difference of the total radius and the center radius, and yeah, that's how you find the overlap of two collided circles. Then next, create two ints, call this x sign and y sign. So these two variables will dictate where the circle that we wanna move will move from its original position to another position. Create an if statement and type C1 center x is greater than C2 center x. So if center 1x is greater than center C2, then the first I wanna move the C1. So if this is greater than this, it means that this is on the right side and the C2 is on the left. So the x sign should be 1f. We want to move this C1 to the left. Otherwise, C1 is on the right. Wait a minute, I got it wrong. So where's the left and right again? If this is true, it means that C1 is on the right. So better. The x sign should be 1f for in order to make this circle move to the right. Otherwise, x sign should be 1f because this C1 is on the left and we need the negative sign in order to make this circle move to the left. And now let's check the y position of both circles. So if center y is greater than C2 center y, then y sign is equals to 1f. Otherwise, y sign should be negative. So if wrong. So if C1 is greater than C2, it means that this circle is on the bottom of C2, and it means that we need to move C1 to the bottom. Otherwise, C1 is on top of C2 and we need to move C1 to the top. And then that's all for this. Kinda confusing. Then next, set the position of C1 because we are going to move C1 in this algorithm. If you want to move C2, then change this to C2, then C1, C2, C1, and C2. I want to move C1, so I'm going to change its position. So C1 dot get x plus the cosine x times the overlap and times the x sign. And next, sec y c1 dot get y, get its original position first, then sin y times overlap, then change the sign. And that's all. Now let's try if this thing is working. Compile. I hope there are no errors. Yeah, there are errors. Yeah, y1f. Come on. It's int. What else? Yeah. Put float here. My mind is kinda clumsy today. Any errors? Yep. Yeah. Use the double equals. And what else? And this. Okay. The square root returns double, and I need to convert it to float in order to put it here in this variable. And what else? Yeah. I'm getting old. Alright. And no errors at last. Thank God. Now let's check if this is working. Alright. No collision. Good. What if there's a collision? And yep. As you can see, C2 does not change its position, its X and Y position, while C1 changed its position because its position before is 207179 and its collision its position now is 228 and 184. Yep. So this algorithm is working. And there's a catch here. I'm going to try if I can reproduce this bug, kind of a bug. Wait. Looks like I can't. As you can see, there's still a collision. Even I already clicked this. Yeah, when I click this, then these two are going to be separated. But as you can see, the program still thinks that there's still a collision. That's because the separation space between these two circles is very thin. So if you want to fix this kind bug, I don't know what to call this. If you want to increase the separation space between these circles, we're gonna put an allowance. We're here in the total radius. Just add 0.5 f, and that's going, and this allowance will fix that thin separation space between circles. So let's try. Going to compile it. And let's try. Yep, now it's working perfectly, and the separation space between circles, yep, are not thin anymore. Yep, so it's working. So you might ask why this allowance works, why this allowance increases the separation space between circles. That's because the larger the radius, the larger the circles are. So if this, for example, if the total radius of these two is larger, it means that this one of the circles here or both of them are large. So by adding an allowance here, this allowance creates an illusion that these two circles are bigger than their original size. Next, we're gonna do the second method. Let me explain the algorithm first before coding. Suppose two circles collide. First off, we need to get the radius in between centers and find the midpoint of that radius that can be perceived as a line segment. Then normalize the radius in between centers and use the normalized values to realign our circle's center along the midpoint by adjusting the distance of circle's radii to the midpoint. So first, we need to get the midpoint or the center point of the radius of the right triangle in between centers. So to do that, create a variable first, get the x and y coordinates of our midpoint. So midpoint x, add both centers, center x plus center y, and then multiply the sum by 0.5 or divide it by 2. Same result, but division is slow, so better use multiply. Next, midpoint y, add c2y, yeah, change this to 2, c1 plus c2, c1 plus c2, but center x, c1 center x plus c2 center x, c1 center y plus c2 center y, then multiply by 0.5, and that's how you get the midpoint of a line. Next, get the center radius. Center radius is equals to, convert the result of math.square root to float radius. Then next, create another variable. So new, this is the new center point of circle 1 or c1, new c1, name it like this, c1 center x new. Get the midpoint x, and add it to the radius of C1, then multiply the radius of C1 to the normalized x of center radius. So get the x length of the right triangle in between centers and normalize it. Alright. Next, C1 center y new equals to get the midpoint y, then get the rad y. You can use a rad x, but I think rad y fits here in this equation because we want to get the y coordinates of our new center point of C1. So C1 center y, and normalize it. Done. And next, create variables for C2 for the new center point of C2. So C2 center x equals to, just copy this to save time and energy. So midpoint x, change this to C2 minus C1, and done. Next, center y new equals to C2 and C2 and C1, and done. Alright, now that we have their new center points and their coordinates, time to set their position. So set x equals to C1 center x new minus C1 dot get rad x. Then C1 dot set y equals to C1 center y new C1 dot get rad y. Next, just copy this with C2 dot set x. Don't wanna type. Change this to 2 and 2. Next, C2 dot set y. Copy this. Just copy this and change this to 2 and 2. And I think the algorithm is done. So let's try this. Compile it first. I hope there are no errors. Oh, misspelled again. Yeah. Alright. And done. And try to run. And check. Yeah. Both circles moved. We can see it here. So before 212, after 210. C2x before 150, now 131. C1y before 165, it moved a bit. Yeah, this one also. Yeah, it's working. Now try it again. Alright, let's check the separation space here, if it's too thin. Yeah, I think it's thin. Yeah, as you can see. Now let's try to add an allowance. To add an allowance, just go here and reduce this to 0.5. When you apply this and you're having some kind of unwanted separation, just use math.abs. That might fix your problem. Alright, I'm not experiencing any unwanted separation, so I'll stick with this without math.abs. And let's check. Compile and run, and let's see if the separation space is good. Yep, no collision. Try again here. Alright, working well. Yep, nice separation space between these circles. Very nice. And that's all for this algorithm. I recommend this algorithm to be used in practice because this is much faster than the first method. And as you can see, I only used the square root. No need to use cos, sine, and a tan. And that's all for this algorithm. Next, we're gonna do the third method. Alright, let's discuss the algorithm first before coding. Suppose two circles collide. First off, get the right triangle in between centers and normalize its x and y components. Then choose a circle that you want to move. I'm going to choose this circle. Since we didn't specify a midpoint, I'm going to use the sum of the circle's radii to realign C1's center along C2's center. This one is very similar to the second method, but we don't need the midpoint here and we're only moving one circle. So first, create float variable named as length x. This will hold the length of the x length of the right triangle in between centers. C1 center x minus C2 center x. Next, length y. Alright, this will hold the y length of the right triangle in between centers. Center y, and good. Next, get the total radius of both circles. Total radius x is equals to C1 dot get rad x plus C2 dot get rad x. Alright, next, get the radius y. Rad y plus C2 dot get rad y. These two are equal because we are dealing with circles. The radius of a circle that is aligned in the x-axis is equal to the radius of a circle that is aligned in the y-axis. In other words, they are equal. However, to make this code more readable, I just follow the normal rule. Yeah, I computed their y, the total radius of both circles that is aligned in the y-axis. You can do this kind of thing like that, but yeah, to make it more readable, I better compute it like this. Next, get the center radius equals to math dot square root radius. Done. Then normalize the normalize this, the length x and y. Float norm x equals to length x divided by center radius. Next, norm y, length y divided by center radius. Done. Then create variables that will hold the new center point of a circle that we want to move. Alright, so C1, I want to move C1, so C1 center x new equals to C2 center x plus total radius x times norm x, and float C1 center y new equals to C2 center y plus total radius y, multiply it by norm y. Got it, and done. And now set the new position of C1. C1 center x new minus C1 dot get rad x. Next, C1 dot set y, C1 center y new minus C1 dot get rad y, and done. Now let's try this, if this is working. Compile it first. I hope there are no errors. Oh my god. Yeah, always getting an error. My mind is clumsy. Alright, forgot to put float here, and that's the only error that. Alright, compiled successfully, and now run it. Wrong spelling. And now this is C1, the moving, the mouse controlled circle. And now let's try this is working. And yep, it's working. C1 has been moved. Yep, 202 from 202 to 223, from 186 to 196. And check if the separation space is thin. Yep, it's thin, as you can see. I already separated them, but still the program still thinks that there's still a collision. Alright, going to fix that. It's easy. Just add some allowance here. 0.5 is alright. It's a good allowance, but we need to add allowance to both this radii. So 0.25f to balance the separation space, or the additional value that we're going to add in the separation space between circles. And yep, 0.25 plus 0.25 is equals to 0.5. And we'll try it again. Compile. Oh, wrong. Where is that? Not that. This one. And no collision. Alright. And the separation spaces, yep, not too thick and not too thin, just right. And yep. I already explained why this works, why the allowance works, because the bigger the radius of a circle, the bigger the circle is. So better add allowance to make it seem big. And another way to add an allowance is by reducing the center radius by some amount, by a little amount would do. Let's try. The hell. And yep, see, the allowance is still good, the separation space is still good. So why this thing works? Why, when we reduce the center radius, the separation space here gets a bit bigger? That's because, look at this. This white line here is the center radius, and there's a triangle here, right? So if you look at this, the closer the two centers are, the closer the two center is, the higher the pushback. As you can see, for example, our circle, or the wait. For example, C1 is here. As you can see, the center of this is close to the center of the green circle, and when the program pushes it back, it needs to push C1 very further. Means the program pushes back the circle by a large amount. But once the circle is just here, the program just pushes back the circle by a small amount. See? So that's why this thing works. It makes the center of the C1 a bit closer to the center of this, thus pushing this C1 a bit further. And yep, that's all for this algorithm. And yep, and that's all for this tutorial. I hope you've learned something from this. Going to end the video and see you later.